Hey kids, and welcome to another week of Art with Mr. P. We are going to start a week-long project this week. So I will have videos every day this week talking about our topic. And our topic this week is going to be color. So we're going to talk a little bit about color and we're going to do a nice color project. But we're going to start by learning a little bit about the science. Like, how does my eye see color? That's a great question, isn't it? Well, I'm going to try to explain that to you today, and I'm going to get you started on on this week's project actually, so that you can have a finished project by Thursday. We'll see if we can get it all finished up by then. I can't wait to see how these turn out. So let's go ahead and start talking about color. Now, color is actually just light reflected off of an object. And the way light works is, here's my sun, for example. Let's say the sun is sending out some light. Yeah, there we go. Say the sun sends out light. When the sun sends out light, we can't see all of the different colors in the sunlight. All right, they're all mashed together, so we can't quite see them, but all colors have a different wavelength. All right, so the sun shoots out these wavelengths, and all the wavelengths are different. For example, blue might look something like this. Red might look something like this. And yellow might look something like this. Okay, all of them are different. Some of them are stretched out, some of them are compressed together, but all of those wavelengths are coming out in the sun. We just can't see them yet. All right, if you have a prism at home and you ever used a prism for an experiment, you'll notice that you can break up the light and you can separate it into its colors. That's exactly how a rainbow works, okay? The light is running through all that wet, moist air from when it just rained, and it's reflecting different colors. That's how a rainbow operates. So as that comes from the sun, it's gonna bounce off of different objects. All right, when it bounces off of different objects, for example, let's take this lemon. Right, when the light shines down on this lemon, color wavelengths like blue maybe are absorbed, meaning the lemon and the surface of the lemon is sucking in that light. And then, but like for yellow, for example, it's not sucking in that light, it's actually bouncing off of the lemon. When it bounces off of the lemon, it's coming into our eyes. Now when that wavelength starts coming into our eyes, okay, something amazing happens. This is why science is so cool. All right, I'm gonna use this ball as my eyeball. Maybe like this. It's a little bit too big, but you guys can get the idea. Now, let's pretend like this is our eyeball. This is the front. That wavelength is coming in. Where's my wavelength? Here's my yellow waves coming into my eye. They go inside my eye. Now, if I were to, ew, gross, slice my eyeball in half and open it up, I would notice that inside my eyeball, I have a couple different things on the inside. So on the inside of my eyeball, I have this little thin layer on the back of my eyeball, and this is called the retina. Now inside the retina, we have all kinds of different little things. We have two different parts. We have this part up here, which we call rods. Rods help us for when we're looking and seeing in the dark. So we're not going to worry about rods today too much. We're going to actually start talking about these guys down here. These are the cones. Now the cones are important. Okay, the cones take all that information and they light up, and when the wavelength hits it, it knows where to go. Now you're going to look at these cones and you're going to say, well, Mr. P, there's no yellow cone there. How do we know it's yellow? Well, actually what happens is our brain is pretty smart. So yellow is close to red and is close to green. So actually the red and the green are both gonna light up, and they're both gonna take in that yellow wavelength and absorb it. And then it runs through all those nerves back to our brain, and our brain says, well, if the red and the green are lit up, that means that it's probably gonna be yellow. So that's how we see colors, okay? Very simple way of doing this, okay? That's the simple science version of it. I'm sure you can find some other more complicated science versions of it, but I'm gonna let the experts do that. But for our sakes, just know that in the back of your eyeball, back here, there's the retina. You got your rods and your cones, and those light wavelengths, after they bounce off of the lemon, are gonna come whoop, and they're gonna light up our cones, and then our brain's gonna tell us, that's yellow. Hey, Mr. P, that's yellow. So that's how we see color. Now, some people can't see color that way. Some people are colorblind. If they're colorblind, that means that their cones are just a little mixed up and can't quite figure things out. So that's not something that we need to worry about today, but we're gonna talk a little bit about the colors and how we use colors in art, because now it's time to start talking about the art part. Now, when we use colors in art, they work a little bit differently than they do in light, because we're actually mixing paint or we're coloring and using colored markers. And that's a little bit different than light, because, like, for example, you're gonna sit here and you're gonna tell me, Mr. P, when I mix red and green together, they don't get yellow. That's absolutely correct. They don't. We're working with the primary colors today. Now, our primary colors are very simple. All right, the primary colors, red, yellow, and blue, are simply the primary colors in art, because I cannot take two colors and mix them together to make blue. Okay, I can't do it with yellow. I can't do it with red. I challenge you to try it. All right, but I know for a fact it doesn't work. So today we're going to talk about primary colors. Now, your assignment today with our primary colors, that's why they're called primary colors, is because you can't mix them with anything. Our primary colors right here, I want you guys to start looking around your house. I want you to look around your house, and I want you to find objects that are the primary colors, okay? So for example, yellow, red, and blue. Now, you're gonna have to be creative. You're gonna have to walk around the house a little bit, and I'm gonna ask you just to collect those colors for now. So what I did was I took some baggies and I just put my colors inside here. See, I started my blue baggie and I've got a lid in here. I've started my red baggie right here with some different things inside it, and I'm actually gonna take this lemon and put it inside my yellow baggie. Right there. There we go. Now it's inside my yellow baggie. Now I'm gonna collect about maybe 5 or 6 different things that are primary colors only. Keep those three bags separate, and just kind of, as you're walking through the house today, look around and see if you can find some other things that you can put in the bag that represent just those colors. We're gonna save those and we're gonna use them later on this week for our project, okay? So, in general, remember that we have the light coming from the sun, bounces off of our object, and after it bounces off of our object, it goes into our eyes, and our eyes then read which color it is and sends it to our brain. Beep, boop, 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 boop. Science, right? So start collecting all of those objects, and let's get started on our big final project that we're gonna do on Thursday. Tomorrow, I'm gonna release a video that talks about 3 more colors. I wonder if you guys can guess which 3 colors I'm gonna talk about. So we talked about the primary colors today, red, yellow, and blue. And then we're going to talk tomorrow about 3 more colors. I wonder if you guys can guess. I bet you guys can figure it out. All right, until tomorrow, have a great day, guys.